Hello, my name is Paul Crump from the Ferdinand-Braun-Institut in Berlin, and I am the current IEEE Photonics Society Chair on Globalization. And I had the great pleasure, together with Fatima Gunning from the Tyndall Institute in Ireland, to host a symposium on globalization in photonics research and development at the IEEE Photonics Conference on the 15th of November 2022 in Vancouver in Canada. This is the first symposium of its kind, and we collected some fine, skilled technical representatives from many of the world's global regions to talk about their work on photonics research and emphasize how they collaborate with different groups around the world. Photonics is a very rapidly developing, highly globalized field where we make joint progress based on great networks and great collaborators from many, many different regions and many, many different backgrounds. So the symposium celebrates this, and we hope to help people make new connections and help this fine work continue in the future. We held the the symposium in Vancouver, which did its job and was extremely charming and beautiful the whole time we were there, and it was a great pleasure to be in this very fine city. So we had a series of excellent speakers. After Fatima gave an introduction from the perspective of the IEEE Photonics Society, then Boone gave a talk about his work in Saudi Arabia and connections across North Africa and the Middle East. Prince gave a talk about medical photonics from Ghana and Central and Southern Africa. Andrea spoke about Central and Southern America and her own nice work on nano antennae. Xiping spoke about silicon-based optoelectronics in China and their connections within China and outside. Dijan spoke about the excellent research in Serbia and the Western Balkans, with his focus on his own work in comb generation. And then Deepa spoke about the progress in fiber optics and photonics in the Indian subcontinent and the rapid changes there. As a wrap-up, then I spoke about the international research outreach from Germany and the European community, with some examples based from my own studies in high-power gallium arsenide-based diode lasers. So this is showing you the breadth of speakers and where they come from. The dots on the map is taken from the Photonics Research Center's connection on the IEEE Photonics Society website. You can see all the many, many groups that work in photonics around the world and who are tied to the IEEE. And then there's pictures of the different speakers and where their institutes are based. So it was a good selection, global selection. So I encourage you to look at their presentations as well. So from my own work, we were talking about the highest efficiency, looking at international research outreach from Germany and the European community in gallium arsenide-based diode lasers, again on behalf of the Ferdinand-Braun-Institut in Berlin. So as a quick introduction to the IEEE Globalization team and their goals, a brief look at the Ferdinand-Braun-Institut in Berlin, a summary of some of the work on high-powered diode lasers at the Ferdinand-Braun, an example of one best case of current international collaboration in the high-power field, and some work we've been doing to make available information on inter-region funding and collaboration opportunities, and then we'll have a conclusion. Okay, so the globalization team itself, this is a collection of pictures of all the different people who are currently active. I'm the chair of the group, and then there's the established communities in the United States and North America in general, and the European community are doing outreach efforts to connect to researchers worldwide. And the community shown here, including Mohammed from my own institute, who's supporting a lot, and Gail, Sinan, and Patrick, who are supporting from the European side. There's connection into the IEEE site, the humanitarian technologies work via Nasia, also from Berlin. And then the African, Middle East, Latin America, Indian, and Chinese communities are all contributing strongly. Lots of exciting grassroots efforts, supported very ably and enthusiastically by Lauren and Lisa from the IEEE Photonics side. Please watch the IEEE Photonics Society website and our social media feeds for more updates on the excellent progress in all the different communities. So we ran as part of Photonics Society, we ran a few needs assessments with discussions held in 2021 virtually at the IEEE Photonics Conference, and in hybrid mode with some of the community in person at the International Semiconductor Laser Conference, which again I had the privilege of chairing and was held in Potsdam in Germany in 2021, in September 2021. So here's a picture from the hybrid meeting some pictures from the hybrid meeting that we held at the at the Semiconductor Laser Conference, excuse me. From these discussions, we had a few needs that were emphasized. For example, the Chinese community emphasized the need for mentoring from experienced scientists. India, like many of us, of course needs funding for their research. Latin America, many comments about helping motivation, access to material in Spanish language, helping with personal career development. Africa was African community strongly emphasized inter-region cooperation. European community, again, inter-region cooperation, access to good people. United States, access to people and mentoring into industry. There's a good spread of interests which we are working hard to support. For example, the Chinese community was setting up a journal club where experienced scientists from, for example, from Photonics Technology Letters would talk through their latest research and how they generated the paper to help the new scientists learning their trade in China help them to learn their field. In the case of exactly. Moving on, we're running out of time. So on to the next thing, operative goals for the globalization team. We want to support access and interaction between regions. For example, this meeting we're doing right now, communication from existing globalization regions, so expanded websites from global regions, expanded European outreach efforts. We've been working to expand our team. We've increased Mideast and African representation, looking at getting more funding for our global studies, inform each other, making cooperation possible. So we're doing regular email updates. We're doing these all global hybrid meetings and teleconferences. We're working towards participating at the Africon in 2023, which I was trying to say in the previous slide, and working hard to be constructive members of our communities. So we participate strongly in science events, for example, the Girls' Days, as held at the Ferdinand-Braun in Berlin, and many of our other partner institutions here in the globalization team. Day of Light, the International Day of Light. We have a long night of science in Berlin where the institutes are open to the public. Lots of efforts to do technician training and collaboration across borders to make that possible. So now an introduction to the Ferdinand-Braun Institute. So we are based in Berlin, Germany. It's got a staff of nearly 400 people from 26 different nations. There's a budget of a little bit more than 40 million euros, including about half of that from research and competitive industrial funds. We're part of a large countrywide collaboration, the Research Fab in Microelectronics in Germany. And a little bit more about that on the next slide. Joint labs with 5 German universities, amongst other many international contacts, and a long record of successful technology transfer, including strategic partnerships with industry and 10 spin-offs. We have 2 different clean rooms, administration and lab space in these two facilities on the left and right. We make semiconductors for new applications and markets. So it's 3 5 semiconductor-based devices and modules for many of the important emerging social needs, covering things like mimics and power electronics, my own work on high-power diode lasers, from the NIR to the UV limiting, light emitting diodes, and so on and so forth. So then we have the the Research Factory Germany. It's 13 institutes across Germany, a series of different scientists, up to 2,000 in a single virtual community, very high levels of investments to give it state-of-the-art infrastructure, and a great place to contact if you need customized devices or modules. Okay, so my own local part of the pie at the FBH on high-power diode lasers. We do studies in experimental physics and device engineering to address industrial challenges in close cooperation with industry. For example, working with Crump on high-power diode lasers, a series of doctoral studies, working with academia, looking at carrier loss effects with Professor Sweeney out of Glasgow, looking at innovative devices and modules to enable emerging applications. For example, ever improved higher intensity diode laser pumps for extreme photonics. And you'll see some more about that in the next couple of slides. looking at innovative device configurations to prepare for a high-power future. For example, creating stabilized broad area lasers and bars, or looking at new technologies such as pixels. None of this would be possible if we didn't have such strong and skilled support from the technology and simulation experts of the team. So we can only make progress in industry-relevant challenges because of the high quality of the infrastructure and the highly skilled and experienced team. We also do work hard to support the community, representing the high-powered diode laser field. For example, chairing the ISLC conference, chairing the semiconductor lasers topic at the CLIO USA, and of course supporting the IEEE's journals such as the Photonics journal, where I'm a senior editor. So as an example of one of the topics in the field, amongst many, there's much work over the last 20-30 years on improving the epitaxial layer structures using ever more sophisticated vertical designs to suppress loss mechanisms to get higher and higher powers. For example, migrating from vertical waveguides with a symmetric profile of refractive index to complicated, highly asymmetric designs, going from thin p-sides to very thick p-sides, with high resistance loss and mechanisms of power saturation, to a very thin p-side, while working to avoid losing performance, to enable low loss, low resistance, and low power saturation. Using designs of this style, we've been able to scale power across a range of different device types. This is just results from the last year. Here, the editor's choice article from Photonics Journal from last year, where we have very high increases in optical power out of a grating stabilized broad area laser, breaking the 20-watt level for the first time and maintaining peak efficiency of over 60% for the first time in a grating stabilized device at 970. Also for pumping narrow lines in ytterbium doped crystals. 780 is a very important material wavelength for pumping thulium lasers. And here we've been able to scale power from peak powers from around 160 to more than 200 watts from a 1200 micron single aperture laser, again by using advances in the epitaxial design. And then single bars. This is the highest reported power at room temperature from a single active region device, getting up to 1900 watts in QC to quasi-continuous wave mode, which again we reported in Photonics Journal at the start of the year, based on 2 results that came out of the Photonics, also shown at the Semiconductor Laser Conference. Another example is improved module design, where you take very high power, high duty cycle modules with multiple water-cooled plates and light emitting vertically, where we had kilowatts of emission demonstrated in 2020, the move through to having in long pulse but 10% duty cycle, scaling this up to 50% duty cycles, so ever more pulses as needed for rapid imaging or rapid material processing applications, also coupling the power into a fiber, and then scaled again to continuous wave in 2022 without any degradation in beam quality or spectral width for enabling material processing applications directly. And again, this is from an invited talk in the IEEE Rapid Conference late last year. So here's an example of international high power collaboration as one example of best practice. So there's a very rapidly emerging, a very exciting technology of extreme photonics. If you can deliver very high energy in a pulsed coherent light source, going from megawatts to petawatts to terawatts in picoseconds to femtoseconds, you can then generate a whole range of very exciting forms of radiation that enable a whole series of new applications that otherwise wouldn't be possible. For example, ultra high power industry, for example, laser shock peening that makes some very dense and robust layers of metal for extreme hardening of metals for for very challenging applications such as turbines in fighter jets or the sidings of nuclear reactors. You can also work to generate power fusion by power generation by fusion, which is again a lot of excitement right now in the community. But you can also use these very intense pulses to generate secondary sources such as proton beams or directed X-rays for different kinds of therapies or imaging. Here's an image of a mouse embryo with extremely high resolution. And of course, if you're going to do this, you need very high, you'd like to have high repetition rates so you can make complicated images very quickly. You can also use these kind of high intensity sources to do next generation particle acceleration by generating a laser plasma in a tiny cell, and then it leaves a wake field behind it, and then the particles in that beam can also be used themselves to generate radiation. So there's a European community, a European-based consortium that's planning on building a large extreme photonics research infrastructure based on plasma acceleration. It's been put on the strategic roadmap, so there's a high chance this will take place. And there's a planning project that started just last year, where the FBH and myself are full members, helping to develop the needed technology and do the appropriate planning for building one of these very high performance systems. So it will build a laser plasma accelerator to help make future science and applications possible. Again, exploiting the latest of high intensity pulse generation based on diode laser pumping, based on diode lasers with the highest possible power, running at the highest possible duty cycle, exploiting the latest research and understanding of devices. Okay, so we have nice work in the Globalization team, nice work at Ferdinand-Braun-Institut, good progress in high-power diode lasers, supported by highly international high-power collaborations. The Eupraxia team has representatives from across the whole globe, many from North America, Asia, and Europe. All of them are making excellent contributions. So if you're yourself seeking funding and see great opportunities for working with groups in other regions, then there is funding available to make that happen. We are collecting this on the Globalization Committee website. There's a European Outreach Forum, and within this web page, there's a funding website, funding side, so you can click on this. And we've collected a series of general calls and country-specific calls that are from the European side, reaching out to help collaborate with countries and regions outside of the European area. So the European Union itself and also the German nation are happy to put money on the table and makes collaborations possible. A couple of examples: if you do general calls, the German Research Foundation has a broad cooperation with developing countries. It's like across the Middle East, Africa, Asia, and South America. Many countries are included within that range, amongst others. So there's the Eureka calls for small companies. So the DFG is academic collaborations. Eureka is focused on small companies typically, as well as humanitarian activities through the IEEE for smaller projects. There are industrial applied collaborative research programs looking at small companies or startups. Currently, there are calls, actually some of this is expired now. They ended at 2022, but we have Canada, Argentina, Canada and Brazil all have or have had collaboration opportunities. For example, Canada and Brazil, you need to move quickly this month in January 2023. When I'm recording this presentation, you can still get an application in. And there's further planned cooperations with Alberta, Brazil, Japan, Singapore, South Korea, Taiwan, amongst others. There's also single researcher positions via the Humboldt Research Fellowships or the George Foster Fellowship, and as well from France from the Eiffel Excellence Scholarship. And there are other similar outreach positions from other nations as well. So do take advantage of it. By all means, contact me or the people on the IEEE Photonics Globalization team. They can help point you to opportunities. Yeah, we hope to make this international inter-region cooperation possible for all of our benefit. So to conclude, there is an active, expanded, productive IEEE globalization team with very clear goals. There's many strong, exciting grassroots efforts ongoing right now. Strategic efforts are coordinated centrally, for example, AFRICON. The Ferdinand-Braun-Institut in Berlin is a highly international excellence center for 3.5 technology, directly with us or via the Research Factory Germany as a one-stop solution. The high-powered diode lasers team is a key part of the FBH, and we're working hard to continue rapid power and efficiency scaling based on strong progress in understanding the limits of packages and devices, based on robust device physics and engineering, showed one example current international high-power collaboration, where high-powered diode lasers are an enabling technology for the emerging secondary source field, in a way acting in the same way as batteries for the electric car industry. Nothing can happen without a diode laser. There are many inter-region funding and collaboration opportunities available. We have some funding listed. Contact us if you need support, but there are also opportunities listed on our new website. And again, to emphasize, the future is global. Thank you very much for your attention. Thank you to the presenters, and do contact me or the presenters from the symposium directly, or the globalization team itself if you have questions or want to follow up. Thank you very much for your attention.